Okay, good morning, welcome to
SuperMath number 19.
SuperMath number 19. We have just pulled a challenge problem out of the book. I have not thought about this problem at all. You've thought about it for about a minute while I was getting the camera. And we're just going to see if we can work through it from our geometry book, okay? So we have a triangle ABC and it has a right angle at angle C. Okay, that's one bit of information. We have these points on AB, which is the hypotenuse, such that AD is equal to AC. And we have this point E such that BE is equal to BC. Okay? And the question is, find angle DCE. Find this angle here. It's kind of amazing that given that they're asking us to find that angle must be some special angle, but it's certainly not obvious what angle that is, right?
Yeah.
And there's hardly any information given about this situation. We know this is a right angle. We know AD is AC, and we know BE is BC. We're just trying to work our way through.
Well, we have two isosceles triangles.
High five. Good. What are they?
We have...
Actually, why don't you highlight them in blue? Does that blue marker work? I don't know how well this will show up.
We've got DAC.
Okay? And AD that's an isosceles triangle. So what does that mean?
These sides are equal.
Those sides are equal.
And these angles are equal.
That angle is equal to...
It's going to be that angle.
That angle is equal to that angle. So, very good. Very good observation. I think that is going to be really helpful to us. Do you have another color? Does this purple work maybe for the other isosceles triangle? Hope they erase.
BE and BC. So EBC.
Okay, and what does this tell us?
These are equal.
Those two sides, those are equal, yeah?
And
okay.
So I'm going to call this one, this is angle 2.
Alright.
And this one's angle 1.
Alright.
So they overlap. So angle 2 plus angle 1 minus our angle we're trying to figure out, DCE,
Yeah.
equals 90.
Oh, wow. That is a great thing to notice. Those two angles that we just found out were equal actually add up to be 90, but double counting the angle we're looking for. Okay? Super. Super. There's one other critical little bit of...
Well, angle 2 plus angle 1 plus angle DCE equals 90.
Why is that?
Because we have this is angle 1,
Yeah?
this is angle 2, and here's our angle.
Alright. And why do those three angles add up to be 90?
Because angles in a triangle add up to be 90. I mean, this is 180.
Oh. How interesting.
Well, maybe we can add these together. Add these equations together.
Okay.
We have 2 times angle 2 plus 2 times angle 1 equals 270.
Alright.
So we can factor a 2 out. 2 times angle 2 plus angle 1 equals 270. Then we divide by 2.
Alright.
So, getting a little low.
That's alright. I think that's on camera. Angle 2 plus angle 1 equals...
270 over 2. Well, it's going to be 135.
Alright, so angle 2 plus angle 1 is 135. Alright, how does that help?
Well, that means that this angle is 180. Angle DCE is 180 minus 135. which is 45.
How about that? It just popped out of nowhere. That angle was 45. Isn't that amazing?
Yeah.
One other way you could have found it, this angle just an inch quicker. The way you did it is totally fine, by the way. But instead of adding these two, subtract them. So you would get the angle 2. So we're going to subtract, here's equation 1, here's equation 2, and I look at equation 2 minus equation 1. So the angle 2 plus angle 1's go away. And I get this angle minus it. So I get twice my angle is 180 minus 90. Twice my angle is 90, so my angle is
45.
okay. But that's just, I wanted to show you that there was a slightly quicker way. But that's fine, what you did is great. So given these very small constraints on our picture, 45-degree angle just appears out of nowhere. Who knew? Well, I guess the guys writing the problem did. But now we do too. All right?
Yep.
All right, that was a really good solution. I would like you to erase the board so the blue and the purple don't stick to the board too much. But great job.